Guys, welcome back, and today we are going to be going over our last section, which is 4.5, graphing inequalities and systems of inequalities. And so for the think slash warm-up, I recall when we would graph something like x is greater than 3 on a number line. When would we use an open dot or a closed dot, and what does the open dot or closed dot tell us? Essentially, we would use an open dot on something like x is greater than 3. So, if I were to actually do that example on our number line, I don't know if 0 is here, 3 is here. We would do an open dot at 3, and since it's greater than, we would shade to the right. And this open dot, essentially we just use for greater than or less than when it was not included. That's what it means, right? This point at 3 is not included. But when we did a closed dot, that would be for greater than or equal to or less than or equal to, and we had that line underneath. And that would tell us that this point would be included if we had a solid dot. And we're going to do a similar thing when we graph linear inequalities, but here's a couple just quick steps. If you want to pause the video and write these down on how to graph linear inequalities, you absolutely can. Basically, I'm just going to graph the line as if it was an equal sign without an equality, and then a solid line, much like we would have a solid dot if it's less than or equal to or greater than or equal to, but dotted line if it's less than or greater than, kind of like an open dot, right? This is kind of like the closed dot, open dot thing, but instead it's going to be for lines, a solid line or a dotted line. And lastly, we're going to shade above if it's greater than and below if it's less than, and we'll get a little more into that with an example. So graph the inequality on the axis below. This is already in slope-intercept form for us, and so we have y, and then again, I'm just going to do it as if this is an equal sign, and the y-intercept is at -4. And we have a slope of -2, which -2 is really -2 over 1, right? And then we can use that rise over run idea, right, for this, right? That rise means 2, go up 2. Run on the bottom is 1. Am I going to go left or right? I'm going to go to the left. Since I want a negative slope, I want the slope to be going downwards. So up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. I can go down 2 to the right 1 as well. And now here, I'm going to draw my line, and it's going to be a solid line because it's less than or equal to. Since we have this or equal to, we know that this is going to be a solid line, and I'm just graphing it as best I can freehand, but it'll be nicer on Delta Math. And then lastly, we need to pick where to shade. So now that this is the third part, is we need to learn where to shade. So since we have y is less than, so here's the line, -2x minus 4. This is the line, -2x minus 4. And we want the y values less than that. So all the y values less than that are really going to be underneath the line. So I'm going to shade in everything underneath this line. So all underneath this line. So all the points on this line and all the points in the shaded area on forever are solutions to this inequality, right? So if you really wanted to check, you could pick a point on this line or any of these points and plug it back into here, and it should work out. So for our second example, you'll notice we do not have y by itself. So we're going to need to get y by itself. In order to do that, we're going to need to subtract 2x from both sides. 2x minus 2x cancels, and I'm left with 3y is less than. 2x and 15 are not like terms, so we have to keep them separate, and I'm just going to put that minus 2x first so that it's in that form that we like to see. Then we have to divide by 3, and when we divide by 3, we have to divide everything by 3. We really get y is less than, and then -2x divided by 3, I'm just going to write that as -2 thirds x. It's the same thing, right, as having that x in the top. And then 15 divided by 3 is 5. And now here I can graph this. So our y-intercept is up at 5. And our slope is negative 2/3. So our rise over run comes in, meaning our rise we go up 2 and then run over 3. So rise up 1, 2 over, and I'm going to go to the left since we have a negative slope and I want it to end up facing down. So up 2 over 1, 2, 3. And then you only need to plot 2 points in delta math, but up 1, 2 over 1, 2, 3. I can go down 2 over 1, 2, 3. Rise 2, run 1, 2, 3. And now, since this is just less than, we're going to have a dotted line. Meaning that all the points on this line are not included in the solution. And then once again, if y is less than this line, we're going to want all the y values that are below this line, right? So I would shade underneath. And delta math has a nice way to shade, right? I'm going to shade all underneath. And so what this is telling me is that any points in this shaded area is going to work for this original equation, but not including the points on this line. Okay. Here, so now we've done systems of equations, and I don't think this is going to be too hard to pick up on, right? We're really just adding is the line solid or dotted, and then shade above or below. So now we're moving on to systems of inequalities, because we've just got off systems of equations, and it's going to be the exact same thing. We're going to graph both of these lines, but the only trick is now our solution is going to be the overlapping shaded regions. So maybe let's start with this one, and I'll do this one in purple. We have plus 3, and then our slope is 1/3, so up 1 over 3, and it's positive, so I want it to be facing upwards, up 1 over 3. Down 1 to the left 3, down 1 to the left 3, down 1 to the left 3, and it's just greater than, so that means a dotted line. And greater than means we're going to want to shade above. So I'm not going to go too crazy with the shading, but we want to shade above. Okay, now let's do this one in blue. So now we're going to do it to the second one. So we're at -5, and our slope is -1, really. There's a -1 in front of there, which is -1 over 1, so up 1 to the left 1. Up 1 to the left 1. Up 1 to the left 1. Up 1 left 1. Down 1 right 1. Down 1 right 1. And again, this one is also going to be dotted because it's just less than. So we're going to dot this line. And now this one is less than, so we want to shade everything below. And now our answer, I'm going to put in green. Our answer is going to be where they overlap. And notice right here, there should be overlap, or there should be purple there. And so we're actually going to overlap only in this little triangle, right? This is our overlap where there's both purple and blue. And then it also says, so what this means is that all the points in this overlapping section, you have to think it's also bigger because, right, this line goes on this way, this one goes on this way, so this section gets wider. But on the graph, we can see this is it. And so all these points here and beyond in this overlapping section are solutions. And so it asks, state the coordinates of a point in the solution set. So we can do that. It looks like -9, 1 is in the solution set. So in delta math, you would just put in -9, 1 would be one of our solutions, right? So let's do one last one, and we'll do this one in purple. Y is less than or equal to x plus 6, so plus 6, and then slope of 1, however you want to graph that. Right, and that's going to be a solid line, and I'm going to do my best to graph it. So that's a solid line there because it's or equal to, and we want less than. So y is less than, so we're going to want everything underneath. So there's everything underneath. If I need to shade more, I can. All right, and then we'll do the next one in blue, which we're going to start at -4, and then -3/2, rise over run, so up 1, 2, 3 over 1, 2, 1, 2, 3 over 1, 2. I can go down 1, 2, 3 over 1, 2, and this one should be dotted, since it's just greater than. So that one's dotted. So here's my first line here. Here's my second one. The first one was solid. This one's dotted. And now this one is greater than. So the shading here is anything above. And so the overlap is this part of the line and all of this in here. Right, so all of this is the overlap, where there is green, or where there is blue and purple. All that overlap. I know it looks a little crazy. If it helps, you can erase the unnecessary stuff, right? So, except you probably want to keep your lines, right? So there we go. There's your true answer. Here's all the overlap. And again, if it just wants you to pick a point in here, looks like 2 zeros a point in there. You could literally pick any point, right? So I don't know, 2 zeros a good point in there. And that is going to wrap up 4.5.